up what she called the top-to-bottom study that picked the 3 most common DRE voting machines used in California and subjected them to serious study by teams of academic experts, including this team, which consists of 5 of my graduate students. The results of this study, and they studied, a set of different academic study teams looked at the Hart InterCivic, Sequoia, and Diebold voting machines. And they found for Hart, it was subject to malicious code viruses that could change votes, and it violated voter privacy. That is, that it was possible to reconstruct who had cast which ballots after the election just using the machine's records. Same thing for Sequoia, both subject to vote-stealing viruses and not protecting voter privacy. Same thing for the Diebold system. A slightly different Diebold system than we studied before, slightly different software, but the same kinds of problems. So Secretary Bowen conditionally decertified all of these voting machines in California. Since then, the state of Ohio has done a similar study called the Everest study with similar results. Okay, so that's sort of the situation. From a public policy point of view, this is a disaster. And the obvious question is, how in the world did this happen? There's not a short or easy answer to that question. I could actually give a whole other talk about that. But regardless of why it happened, and it really required I guess the short answer is it required a whole series of bad luck and bad decisions and risk factors. Anyway, the question arose, what should we do? Now, one answer that you sometimes hear, and you see it here, what to do, and you see it here, is the call to dispense with computers entirely in voting. So this is an entry from Daily Kos, which is a very popular political blog of the liberal bent. And it says, call your congressman and tell them that we want to ban all use of computers in voting. Let's go back to pieces of paper on which the voter writes with a pen or pencil, counted by a human being. This is a system that we've used for a long time, and we're by now well acquainted with its failure modes and with the sorts of fraud that it allows due to tampering with ballot boxes and the like. This is not, of course, the answer. Here we have a human being counting a ballot that the voter marked manually. So this may not be the best solution anyway. In any case, electronic voting, the use of computers has certain advantages over all paper systems. Voters seem to prefer electronic systems for a number of reasons. It gives you faster reporting of the results, which is not only a nice thing to have in a now media age, but it also is a security property because there's a window of vulnerability between the time you close the polls and the time that you tabulate the votes. And you can keep that window shorter by reporting and tabulating votes more quickly. There's less time for mischief. There's less time you have to guard the media and the machines and so on. You have fewer undervotes potentially because the machines can help the voter know that they're casting an illegal vote. If the voter tries to mark a second candidate for president, the machine can say, no, that's a problem. If you want to vote for this candidate, you need to clear your vote for the other one. You can warn the voter that they're maybe casting an invalid vote, and the hope is you get fewer invalid votes. You have potentially improved accessibility. You can have different interfaces for people who are blind. You can give them an audio interface. People who lack fine motor control, you can give them a different user interface with great big buttons, and so on. You can present the ballot to people in a different language if you want to do that. So maybe improved accessibility and potentially increased security. I've put that in red with an asterisk because although we know in the research community methods that we could use for example, involving certain uses of cryptography that would make voting more secure by taking advantage of what computers can do, none of the actual voting systems that are in use really take advantage of those fully. Nonetheless, electronic voting has advantages. So I believe the solution is not to throw computers out entirely, but to figure out how to do better in using computers in voting. And I want to spend the rest of the time talking about how I think that would work. Okay. The first piece of the answer, and this is something that computer scientists who have studied this issue, I think, mostly agree upon, is to use a system that keeps both electronic and paper records of the ballot. With the paper record, something that is viewable and verifiable by the voter directly. And there are basically two kinds of systems that can do this. On the top here, we have a touchscreen or DRE system, which has had a voter verifiable paper trail added to it. So the voter goes to the touchscreen, they choose their candidates. When they say they're done, the system then prints out a paper record that says, here's how I think you wanted to vote. And the voter can look at that and say yes or no. If they say no, then the computer prints void all over it and discards it, or actually keeps it, but keeps it marked void. If the voter says, yes, it's what I wanted, the ballot is saved in some sort of a ballot box so that the paper record is available afterward. The other option to get both electronic and paper records at the end of Election Day is what's called precinct count optical scan system. Here the idea is you have a paper ballot that the voter marks by hand with a pen or pencil, and as soon as the voter has marked the ballot, you run it through a scanner, and the scanner will read it. It will check to see whether it's valid. If it appears to be invalid, say a double vote in some race, it will kick it back to the voter so the voter can fix the problem. If the ballot seems to be valid, the machine will make an electronic record of the ballot, and it will also feed the ballot through into a ballot box where it's collected later. Either way, at the end of Election Day, you have the electronic record that was captured right then when the voter cast the vote, and you have a paper record which was, at least in principle, verified by the voter. Now, why is it good to have electronic plus paper records? The answer has to do, I think, with the failure modes of electronic versus paper systems. They have different kinds of failure modes. With paper ballots, you're worried about physical tampering with the ballot box and with the ballots. With electronic records, you're worried about what, for lack of a better term, I'll call cyber tampering. Someone changing the code in the voting machine is really the attack you worry most about. With paper ballots, you worry about retail-level fraud. That is, somebody messing with ballot boxes, one ballot box at a time. It requires handling a large amount of material to large amount of stuff, maybe in a large number of places to steal a large number of votes. With electronic records, you're worried about wholesale fraud. Someone is going to commit a bad act once in one place, and it's going to have a widespread effect. Retail attacks are usually easier to carry out, but wholesale attacks have worse consequences if they are carried out. With paper ballots, you worry primarily about fraud that happens after the election. Someone gets to the ballot box and puts stuff in or takes stuff out, or just throws the whole ballot box away. With electronic records, you're worried primarily about tampering before the election, something that's going to change the software in the voting machine. And in fact, if the electronic record is recorded in a way that uses cryptography cleverly, then you can ensure that if there has not been tampering before the ballot is recorded, that any tampering after that is detected. So what you can see when you compare these across on this list is that you see different kinds of failure modes in the two cases. And in general, when you have redundancy, and the redundant systems have different failure modes, then you tend to get greater security, and by the way, greater reliability as well. An attack that modified both the electronic and paper records in a way that was consistent would have to involve physical tampering and cyber tampering, would have to involve both retail and wholesale fraud modes, and would have to probably involve a component before the election and a component after the election. That's more difficult to carry out. Okay, so paper plus electronic records offer potentially greater security. On a public policy front, there's been legislation proposed by Representative Rush Holt, who's actually my congressman in Princeton, H.R. 811, the Voter Confidence and Increased Accessibility Act. This is now currently in the House of Representatives. There's a similar bill in the Senate. It would require that there be a voter verifiable paper record and that there be random manual audits to compare the paper and electronic records after the election. It would require increased access, not unlimited, but increased access to voting software and source code to let officials verify security. And it would provide some additional money for the states to improve their voting systems. This bill is, as I said, in the House. There's a similar bill in the Senate. Both of them are stuck, very unlikely to get passed. There's been strong opposition from state and local officials to this because, for a number of reasons, but I think largely because they worry about the cost and complexity associated with changing to a different voting system. Because this bill has been passed, there's a simplified version of the Holt bill, which was recently introduced, I think this week, if I remember correctly, H.R. 5036, that says basically this, that if your state used paperless voting